This is question number 1 in the calculator paper. There are 2.69 million vehicles in Scotland. It is estimated that this number will increase at a rate of 4% each year. If this estimate is correct, how many vehicles will there be in 3 years' time? The first thing we want to do here is write 2.69 million in figures so that we can type it into our calculator. So that's 2690,000. The question indicates that this amount will increase at a rate of 4% each year over the next 3 years. Because we are speaking about an increase of 4%, that's adding 4% to the original value of 100%, which is 104%. And that as a decimal is 1.04, which is the figure we multiply by. And because it's a period of 3 years, then that's our power. We need to now put this into a calculator to get our answer. Now, the figure returned by the calculator when we do this is 3,025,884.16. Now, since this figure is an estimate, we obviously want to round it in some way. So what we'll do here, it doesn't indicate what to round it to, but we'll round it to the nearest 1,000. So that will be 3,026,000 vehicles. That's our estimate and the end of our question. This is question number 2 in the calculator paper. A container for oil is in the shape of a prism. So there's our first important word. The width of the container is 9 centimetres. That's from here to here. The uniform cross-section of the container consists of a rectangle and a triangle with dimensions as shown. So the cross-section is this part here, which is then shown over here, face on. We can see that we have our triangle shape at the top and our rectangle down at the bottom. The question asks us to calculate the volume of the container and correct our answer to the nearest litre. So the first thing that we need to know is how to find the volume of a prism. Now the volume of a prism V is the area of the cross section multiplied by the length. So that means what we're going to do is we're going to have to find the area of the cross section, the one I highlighted a moment ago, and multiply it by the length, which is known as the width in this question. So the cross section, as it's stated in the question, is made up of a rectangle and a triangle. So there's our rectangle. We can clearly see the length and breadth. And then our triangle at the top. We'll need to know the base and height to work out the area of that part. So the base is quite clearly the same as this measurement down here, 20 centimetres. The height of the triangle, however, this part from here to here, isn't stated. But it should be obvious that the height that I mentioned a moment ago is just the difference between the height of the whole cross section, take away the height of the rectangular part, leaving us with the height of the triangle, which will be 4.5 in this case. In order to clearly distinguish the two separate area parts, I've coloured in the rectangle green and the triangle red. I'll now give us a little bit more space to work out the area of both of those parts. So first of all, the area of the rectangle. So the area of a rectangle, you should know that the formula for this is area A equals the length times the breadth. That means our area A equals 20 multiplied by 28, and that then gives us 560 square centimetres. Next thing we want to do is look at the triangle. So we'll put the work in for that alongside. Now, once again, we should know already that the area of a triangle is a half times the base times the height. So that's a half multiplied by the base, which we already noted was the same as the measurement at the bottom, which is 20, multiplied by the height, which was going to be the difference between the total height and the height of the rectangle. So that's 32.5 take away 28, which is 4.5. Now, once again, we can use a calculator if we really need to, since it's the calculator paper. But just like the previous calculation, we should be able to work this one out without. So we've got a half times 20, which is just 10, and 10 times 4.5 is 45. So that's 45 square centimetres. So what we want to do now with these two areas is add them together to find our total area. So I'll just move this up a bit. So total area is equal to 560 plus 45, which then gives us 605 square centimetres. So that's the total area of our cross section. We want to now take that area and multiply it by the length to find the volume of the prism. So we'll move our picture down a little bit. Okay, giving us a bit more space. So like we said, the volume of a prism, V equals A times L. So we'll do that over here. The area being the one we just worked out, the cross section, which is 605, multiplied by the length, which you might still be able to see here, is 9 centimetres. So working that out gives us the volume of our prism, which is 5,445 cubic centimetres. So that is our answer, but if we recall exactly what it said in the question at the end, the question said calculate the volume correct to the nearest litre. So we'll need to convert our answer into litres. So what we have at present is our answer in cubic centimetres. We should know that there are 1,000 cubic centimetres in a litre. So that means that our volume here is actually 5.445 litres. And rounding that to the nearest litre, the answer would simply be 5 litres. That's our final answer and the end of the question. This is question number 3 in the calculator paper. A sector of a circle centre O is shown below. The radius of the circle is 2.3 metres, so that's shown here. Angle AOB, which indicates this angle here, is 65 degrees, and the question asks us to find the length of the arc AB. Now the arc AB is this part here, I'll mark it in green, which is part of the circumference if it were a full circle. We only have a part of the circle, so it's referred to as the arc. So as we said, it has something to do with the circumference, and the circumference of the circle is equal to pi times the diameter. So the arc length contains that also. So our arc length formula is pi times the diameter multiplied by our angle divided by 360 degrees. So that's pi multiplied by our diameter. Now what we have is the radius, which is 2.3 metres. So our diameter will be double the radius, which means our diameter is 4.6, and that's multiplied by the angle at the centre, 65 degrees, divided by 360 degrees. So we can now put this into a calculator to find the length of the green line, the arc, which is in fact 2.61, and that's meters. That's correct to 3 significant figures. That's the arc length. That's our final answer. This is question number 4 in the calculator section. The price for Paul's summer holiday is £894.40. The price includes a 4% booking fee. What is the price of his holiday without the booking fee? This question is an example of reversing the percentage change. The original price of the holiday is what we are looking for, which would be represented by 100%. What we have, however, is the price including the extra booking fee which has been added. So our price is represented by 104%. So this amount is the amount shown at the top, £894.40. We need to get back to 100%. So since we have a calculator available, what we want to do in our next step is find out what 1% would be. In order to do that, we're going to divide both sides by 104. That then gives us 8.6. So we'll drop the pound sign just for this intermediate step. And we want to get back to the original price, which would be represented by 100%. So now we will multiply by 100 on both sides. That then gives us 100% equals 860. That's pounds. That's the original value of the holiday and the end of the question. This is question number 5 in the calculator section. A necklace is made of beads which are mathematically similar. The height of the smaller bead is 0.8 centimetres and its area is 0.6 square centimetres. The height of the larger bead is 4 centimetres. Find the area of the larger bead. Now, since we are talking about area, we will need to square the scale factor when we carry out this calculation. We are looking to find the area of the larger bead, so that means we're going to multiply the area of the smaller bead, which is 0.6 square centimetres. So we're going to multiply that by the scale factor squared. So to find our scale factor, we take two corresponding lengths, one from the new shape, the one we're trying to find, divided by one from the old shape. And as I've said, since it's area, we'll need to square it. So that's going to be 0.6 multiplied by, and then we can take the height, which is 4 from the new shape, divided by the height from the original shape, which is 0.8, and then we're going to square it. So moving this up a little bit, that then when we multiply it out on our calculator will give us exactly 25 square centimetres. That's the area of the larger bead and the end of the question. which gives us £4.80, which we'll just write as 4.8 while we're doing the calculation, divided by the horizontal distance on our triangle, which is here to here. So that's 0 to 4, so that's just simply 4. So that means our gradient will be 4.8 divided by 4, which gives us 1.2. So now we know our gradient is 1.2. We can substitute that into our equation, y equals mx plus c. So in this case, y is in fact called the f-axis for fair, so we're going to change y to f, and the x is in fact the d-axis, so we'll change our x to d. So that means we have f equals the gradient, which was 1.2, times x, which is now d, plus the y-intercept, which is 1.8. So we are talking about sums of money, but we'll leave it as 1.2 and 1.8 for the purposes of the equation. So that's the answer to part A. The question then in part B goes on to ask us to calculate the fare for a journey of 7 kilometres. So this 7 kilometres is going to be the distance d. So that means we can use our equation f equals 1.2d plus 1.8 to work out our fare. So that means our fare will be 1.2 multiply the distance, which is 7, plus 1.8, which when worked out on our calculator gives us an answer f equals 10.2. Now at this point we should remember we're obviously talking about a taxi fare, so that means we need a pound sign and 2 digits after the decimal point. So the taxi fare for a journey of 7 kilometres should be £10.20. Question number 7 in the calculator paper. f of x equals 3 sin x, and then we're told alongside it that x has to lie between 0 and 360 degrees. Part A, find f of 270. So what's happened here is that x up here has been replaced by 270. So we can substitute that into our formula. So I'll write down the formula first. That was f of x equals 3 sin x, our function. We want f of 270. So we've replaced the x by 270 degrees. So we'll do that along here as well. So that's 3 sin 270. Now with our knowledge of our sine graph, we should maybe be able to remember that 270 degrees gives us a value of -1. If you don't know that, however, you can use your calculator here. So that means we get 3 times -1, which then gives us -3. So that's our answer for f of 270 degrees. Part B tells us that f of t equals 0.6, and it asks us to find 2 possible values of t. So first of all, the t replaces the x up here, so that's what we can do to begin with. We can rewrite it in terms of t. So I'll move this up. F of x, as we know, is 3 sin x. So what that means is that f of t is equal to 3 sin t. Now the question asks us to find 2 possible values of t, given that f of t equals 0.6. So we have f of t equals 0.6 here, but we also have f of t equals 3 sin t. They're both f of t, which means they must both be equal to each other. So that means that we can write 3 sin t is equal to 0.6. Now in order to find t, the first thing we want to do here is move 3 onto the other side. So since 3 is multiplying the sign in here, when we take it to the other side, it will change to the opposite, which means it changes to divide. So that will be sine t equals 0.6 divided by 3. Now, in order to find t, we should be aware at this point that we're going to have to find the inverse sine of 0.6 over 3. We should also be aware that since it says find two possible values of t, that this question is going to involve our cast diagram. Now, since sine t equals a positive value, it actually makes this next part fairly straightforward. So the inverse sine of 0.6 over 3, we can do that on our calculator, which gives us 11.5 degrees. So we're going to take this associated acute angle and we're going to use it in our cast diagram, which we'll draw over here. So that's our all quadrant, sine quadrant, tan quadrant and cos quadrant. Since sine t was equal to a positive number up here, that tells us that we're going to tick the all and the sine quadrants. So what that means is that the value from our calculator, our first value, 11.5, is one of the answers for t. So t equals 11.5 degrees. Now our second value will come from the sine quadrant, and in this quadrant it's 180 take away 11.5. That gives us 168.5, which is our second value for t. We now have our two required answers for t, and that's the end of the question.